Welcome to the next installment in my video lecture series in economics. And in this particular video lecture, I'm going to be taking a look at a question from a homework assignment in my Managerial Economics course, particularly Chapter 6 homework, question 30. It states, consider the following production function. Q equals 100L to the 0.7 power, K to the 0.2 power. So we're given our Cobb-Douglas production function here. Currently, the wage rate W is $20 and the price of capital R is $10. If the firm uses 20 units of capital, how much labor should be employed to minimize costs? So I think the key block that students had here was forgetting what the cost minimizing condition is. The cost minimizing condition is the marginal product of labor divided by the wage rate is equal to the marginal product of capital divided by the cost of capital, or sometimes I say the rental rate of capital. So that condition holds, we're minimizing costs. So we have to remember that. We've already got W and R given to us. So we can insert those into the cost minimizing condition. So we get the marginal product of labor divided by 20 should equal the marginal product of capital divided by 10. So we need to use the production function to come up with the marginal product of labor and the marginal product of capital. And we do that by taking the derivative of the production function. So we take the derivative of the production function with respect to L to get the marginal product of labor. And then to get the marginal product of capital, we would take the first derivative of the production function with respect to capital. So if I do that for labor, I get that the first derivative is equal to 70L to the negative 0.3 power, K to the 0.2 power. All right, and it's just a quick review. When we're taking the derivative here, we're taking the derivative of the production function with respect to L. We take the exponent on whatever we're taking the derivative with respect to and multiply that out front. So we have 100 multiplied by 0.7, which gives us that 70. And then we subtract off 1. All right, we lower the exponent by 1 power. So it's 0.7 minus 1, so it's negative 0.3. And capital is remaining unchanged here, so it's considered as a constant, so we just have K to the 0.2 as it appears in the original production function. We do the same thing with the production function, except now we take the derivative with respect to capital, and that gives us 20L to the 0.7 power multiplied by K to the negative 0.8 power. Again, as a review, we're taking the derivative with respect to K, so whatever exponent is on K, we multiply that out front. 100 times 0.2 gives us 20. All right? And we subtract 1 off of that exponent, and that gives us negative 0.8. So we have the marginal product of labor here and the marginal product of capital, which we can insert into our cost minimizing condition. Now realize that we can simplify this down. For example, we can multiply both sides by K to the 0.8 power. All right? So if we multiply this side by K to the 0.8 power, we get K to the 0 power, which is equal to 1. So that negates. And we can multiply this side by both sides by L to the 0.3 power. So L to the 0.3 power multiplied by L to the negative 0.3 power is L to the 0 power, which is equal to 1. So this drops. And we have L to the 0.7 power multiplied by L to the 0.3 power. That's L to the 1. So rewriting that, we end up with 70K over 20 is equal to 20L divided by 10. So we have 70K divided by 20 equals 20L divided by 10. We know what capital is. We were told we have 20 units, so we can insert that in there. And we can solve for L, and that gives us that we need 35 units of labor when we have 20 units of capital in order for us to be minimizing our costs.